Welcome to lesson 7A.1. Today we will be simplifying polynomials by adding, subtracting, and multiplying. You've seen polynomials before, you just may not know that you have seen that. So before we get to actually simplifying them, we need to know how they need to be written. So the standard form of a polynomial is something like this: x cubed plus x squared plus x plus c. C is going to be a number. The other terms are always going to have a variable. The important thing about standard form is that they go in descending order, meaning you have to look at the exponent and they have to go from biggest to smallest. So in this example, it goes 3, 2, 1, none, because this one does not have the x variable. So let's look at the following examples. So for number 1, we're going to simplify the polynomial expression. This is an expression because there is no equal sign. But when we simplify it, we have to make sure that we write it in standard form. When you're simplifying polynomials, all you're really doing is combining like terms. So if I look at the four terms, 5x, 24, 6x, and negative 13, I have to combine the ones that are alike. So these four, the ones that are alike, are 5x and 6x. And I'm going to go with those first because that one has my variable. And then 24 and minus 13 are just a number. So you always want to go with your variables first. So 5x plus 6x is 11x, and then all I have left are the numbers without variables. 24 minus 13 is positive 11, and that's my answer, 11x plus 11. So in number 2, we're going to do the same thing. 5x plus 24 plus 6x minus 13 plus 5x. So it's the same thing as number 1, but we added the 5x at the end. So start with your variables, like terms, 5x plus 6x plus 5x. And I missed this minus 2x here. So these four things need to be combined. They're like term because they have the same variable. So 5 plus 6 is 11, minus 2 is 9, plus 5 is 14. X. When you're combining like terms, you're really just combining the numbers. The variable is going to stay the same. So 5 plus 6 minus 2 plus 5 is 14. They don't have the x, so you have to make sure that that has the x as well. And then I have 24 minus 13 is positive 11. So now let's move on to number 3. Now I have 5x plus 24 plus 6x squared minus 13x plus 2x squared. Well, now I have a variable that has an exponent. So I have to take that into consideration as well. So because I know standard form starts with the biggest exponent, that's where I need to start combining like terms first. 6x squared plus 2x squared. That is 8x squared. You are only combining the numbers. The variable behind the number is going to stay exactly the same. So don't try to add those two exponents. It stays exactly the same. Now I go to my x's. 5 minus 13 is negative 8. Have to keep the variable x. And then 24, there's nothing to combine it with, so you just bring it down. Now, numbers 4 through 6 are a little different because they have different sets of parentheses. If you have something in front of parentheses, remember you always have to distribute. So, if I look at number 4 in front of my first set of parentheses, I have nothing there. So I can just rewrite 5n plus 6n to the 4th power. In front of the second set of parentheses, I have a positive. If I distribute that positive, everything is going to stay the same. So I can just bring everything down from the second set of parentheses. Plus n to the 4th minus 5n. Now I start combining like terms just like we did in the first 3 examples. So we always start with our highest exponent variable. In that case, it is 6n to the 4th plus n to the 4th. Well, 6 plus 1 is 7n to the 4th power. And then I go to my terms that only have a variable. 5n minus 5n is nothing. It cancels out. So you could put plus 0, or you could just leave it as 7n to the 4th power. So number 5, x minus 8x cubed. Nothing's going to happen. I don't have anything to distribute in the first set of parentheses. But in the second set of parentheses, I have a minus. I could put a 1 in front and then distribute a negative 1. So negative times a positive 6x is a negative 6x. A negative times a positive 5x cubed is a negative 5x cubed. So you have to make sure you distribute that negative, or you can think of it as distributing the negative 1. Now we just combine like terms. Start with the variable with the highest exponent. Negative 8x cubed minus 5x cubed is negative 13x cubed. And then I just combine my x variable values. 1x minus 6x is a negative 5x. First parentheses, I have nothing to distribute up front, so I can just rewrite everything that's in the parentheses without the parentheses. In the second set of parentheses, I have to distribute that negative. So this becomes minus 3x cubed, and then this becomes plus 8x squared. A negative times a negative is a positive. So now we combine like terms. We always start with our largest exponent, and that is x to the 3rd power, or x cubed. So 7x cubed minus 3x cubed is 4x cubed, or 4x to the 3rd power. Then I go to my exponent of 2. Negative 2 plus 8 is a positive 6. Keep the variable the same. And then the last one all by itself, you just bring that down, plus x. So that is when you are adding or subtracting to combine like terms. You might have to distribute, but then when you combine like terms, you're either just adding or subtracting those numbers in front of the variables. Now, number 7 is a little different because I have 2 sets of parentheses next to each other, but there's no sign like we had up here in 4, 5, and 6. So when I have 2 parentheses next to each other, that means I'm going to multiply. You already know how to do this. I'm going to show you how to do it 2 ways. The first way we've already done before. So the first method is to do the box method. So I set up my box. I write these on the top and on the side. And then remember to fill in the box we multiply. X times x, x squared. 5 times x, 5x. X times negative 6, negative 6x. Negative 6 times positive 5 is a negative 30. So once you fill in your box, we're doing everything we already did up here. It just looks different. So I'm going to combine my like terms. My like terms are my 2 x variable values. So we always start with the biggest exponent first, which in this case is x squared. 5x plus negative 6x, or 5x minus 6x, is negative x. You can put a 1 in front, but it won't be there. And then minus 30. So that's option 1, which we've already done before. Option 2 is called double distribute. And what you do is exactly what the title says. So I have x plus 5 and then x minus 6. So I'm going to distribute everything in the first parentheses to everything in the second one. So x times x is x squared. And then x times negative 6 is negative 6x. So that's the first part of the double distribute. Then I have to distribute the second part of the parentheses to everything in the second parenthesis. So this is where the double part comes in. So then I have to distribute 5 times x is a positive 5x. And then 5 times negative 6 is negative 30. So now these look just like the first few that we worked out. We just have to combine like terms. Well, there's nothing to combine x squared with. My two like terms here are negative 6x plus 5x. That's going to give me with, or leave me with negative x, then minus 30. So we get the same answer. You get to choose what you like better. So you can either do the box method or you can double distribute. So in number 8, we have the dimensions of a rectangular garden. The length is 2x plus 4 and the width is 3x minus 5. We want to know the area of the garden. Well, to find the area, I need to do length times width. So that looks like 2x plus 4 times 3x minus 5. So this is still either a box method or double distribute problem. It just comes in the form of a word problem. So I'll do both. Box method first, and then I will double distribute. So I have 2x plus 4 and 3x minus 5. This one looks a little different because we haven't seen any numbers or coefficients in these first terms. So in this first box, we've always just had x squared because we had x and x. Well, now we have numbers in front. So all we're going to do is still multiply. 2x times 3x. Well, 2 times 3 is 6. X times x is x squared. So you're still multiplying. 4 times 3x is 12x. 2x times negative 5 is negative 10x. And then negative 5 times positive 4 is negative 20. Combine like terms. Remember, if they are set up in standard form before you multiply, then your like terms will always be diagonal from each other. 6x squared, there's nothing to combine that with. 12x minus 10x is a positive 2x, and then minus 20. So that's the box method. Now I will double distribute. So 2x times 3x, 6x squared. 2x times negative 5 is negative 10x. First distribute, here comes the double. 4 times 3x is 12x. And then 4 times negative 5 is negative 20. My like terms are in the middle. So I end up with 6x squared. Negative 10 plus 12 is a positive 2. Don't forget the x. And then minus 20. So we end up with the exact same answer. You can choose the method. If you like the box method, set up your box. Multiply to fill in your 4 squares. Combine like terms. Write it in standard form. If you like to double distribute, make sure that you distribute both things into the second set of parentheses. And then if you set it up correctly, your like term should be in the middle. Combine those. Make sure it's in standard form. So the next page. Number 9 looks a little different. We saw something like this when we worked with writing the equations in standard form the last lesson of the previous packet. So remember that this squared here, this exponent of 2, tells me I'm going to write this thing 2 times. So what this whole thing actually means is I have x plus 5y times x plus 5y. I'm multiplying the same thing by itself. Now notice also we have a different variable. We used to only have x, now we have x and y. So in these examples where you have multiple variables, you need to make sure that you write them in standard form, but also in alphabetical order, because we have different letters, different variables. So, box method, x plus 5y, x plus 5y, x times x, x squared, x times 5y is just 5xy. You can't combine those variables because they're not like terms, they're not the same. So you just put them next to each other in alphabetical order. So this box will also be the same because I'm multiplying the same thing, x times 5y, so 5xy. Now here 5 times 5 is 25, y times y is y squared. My like terms are still diagonal from each other. Those are the only ones that I can combine because they have the exact same variables. So I end up with x squared, 5xy plus 5xy is 10xy, and then plus 25y squared. So this one goes before this because this one still has an x. This one doesn't. So in the alphabet it's x, y, z. So x, x, y, and then just y by itself. Okay, so now with we'll distribute x times x, x squared, x times 5y, positive 5xy. Remember, just put them in alphabetical order. The double part, 5y times x plus 5xy, 5y times 5y is a positive 25y squared. Combine like terms. Remember, the variables have to be exactly the same to be able to combine them. X squared plus 10xy plus 25y squared. So, for 10, I will only do the box method. If you like to double distribute, you can double distribute and then check your work after I come up with the answer. So, box method. We have 2x plus 4y, and then 3x minus 5y. So don't let these numbers in front of these x's confuse you. Just multiply them. 2 times 3, 6x times x, x squared. 4 times 3, 12, x times y, xy. Don't forget about alphabetical order. 2 times negative 5, negative 10, x times y, xy. 4 times negative 5, negative 20, y times y, y squared. Like terms, diagonal from each other because we set it up correctly before we started multiplying. There's nothing that has just an x squared, so 6x squared. 12xy minus 10xy is a positive 2xy, and then minus 20y squared. So for number 11, I'm only going to double distribute. So if you want to do the box method, do the box method, and then check your answer after I finish double distributing. So 8x times 8x is 64x squared. 8x times 4y, 8 times 4, is a positive 32. xy, just go in alphabetical order. So that's the first distribute. This time, don't forget about that negative sign. It's attached to the 4. So we have to distribute negative 4y. So negative 4y times 8x is minus 32xy. Negative 4y times positive 4y is negative 16y squared. My like terms are my 2xy terms. 32xy minus 32xy, they're going to cancel out. So all I'm left with is 64x squared minus 16y squared. Now, number 12 looks different. It looks somewhat like these two up here, right, when we write them all out, or like this. But if you notice in the second parentheses, I have 1, 2, 3 different things instead of just 2. So when you have something like this where you have 2 and then 3, use the box method. Your box method is going to have to look a little different because we can't fit these 3 and just these 2 here. So this time we're going to make the box a little bit bigger to make sure that we can fit everything in it. So still 2 on the side, but now instead of 2 at the top, we have to make it by 3. So this is only 2, right? 3x and 5, well, that needs to go here because this is the part where I have 2 different sections. So 3x plus 5. This part that has 3 needs to go up at the top. So 2x squared plus 3x minus 6. So we just have an extra column of boxes. You're still going to multiply to fill them in, just like when we have only 4 instead of 6. So 2 times 3 is 6. X squared times x is x to the 3rd power. Because I already have 2 x's here, I have 1 more here, so that makes a total of 3. We'll get to laws of exponents later. 3 times 3 is 9. X times x is x squared. Remember, you are multiplying to fill in these boxes, not adding. Negative 6 times 3 is negative 18. X, because I only have 1 x. Now the bottom row, 2 times 5 is 10. Just x squared, because I don't have any variable here. You can't forget it. You just kind of bring it down. 3 times 5 is 15. X, no x, so just x. And then this one is just numbers, no variables. Negative 6 times 5 is negative 30. So now this is more like the one that was on page 13 of your last packet where we had that bigger box. I think there were like 12 different boxes. We're just combining like terms. We have to start with the biggest exponent. So the biggest exponent I see is 3. Well, there's nothing else that has an x to the 3rd power, so it is just 6x to the 3rd power. Now I move to x squared. Well, this has an x squared and this has an x squared. My like terms are still diagonal from each other. So 9x squared plus 10x squared is a positive 19x squared. So now I move to just my x. Well, these two are just an x without an exponent. So negative 18x plus 15x is a negative 3x. And then this one, there's nothing else, that's just a number. So we just bring that down. So minus 30. Fill in your box by multiplying, combine like terms by adding. 13. Simplify the following polynomial expressions. Well, I have a lot going on here. I have 2 things that have an m squared, but then I have this parentheses and something in front of it. We always have to follow order of operations. So before I start doing anything else, I can't combine yet. I have to distribute this negative 2/3 to only what is inside the parentheses. So this 9m squared, I'm not going to worry about right now. It's going to stay the same. I'm only worried about this little piece right here because that negative 2/3 is directly in front of the parentheses, which has 3m minus 7. So I'm only going to distribute it to what's inside the parentheses. So negative 2/3 times 3 is, well, times 3m is negative 2m. You can use your calculator. Negative 2/3 times negative 7. Remember, 2 negatives make a positive, and that's going to be 14/3. Now, these 2 things up at the front and at the back, I didn't touch, so I just bring them down. So 9m squared plus 5m squared. Well, now I just combine like terms. I have to distribute first, but now I just combine like terms. These are my 2 like terms. We start with our biggest exponent. 9 plus 5 is 14. Don't forget the variable, m squared. Next is just the variable m with no exponent. That's the only one I have, so I just bring it down, minus 2m. And then at the very end, I just have the plus 14 over 3. Do not change it to a decimal. This could be converted to a decimal, so it's just a number, but leave it as a fraction. All right, 14 is similar. We have to distribute what's in front of the parentheses first. So I have to distribute 3x times 1 over 3y. Well, 3 times 1/3, or 3 times 1 over 3 is just 1. And then x times y is xy. 3x times negative 9. 3 times negative 9 is negative 27x. So I'm done with that part. So now for the next parenthesis, I have to distribute this negative 7. Well, negative 7 times x is negative 7x. Negative 7 times positive 1 is a negative 7. Done with that part. This time I'm distributing a y. Y times x, remember alphabetical order, so positive x, y. Y times 4 is a positive 4y. So here we're just distributing what's in front of each set of parentheses. So this can be rewritten like this. Well, I can make it look less complicated. I can make it look shorter. I have to simplify. The only way to do that is by combining like terms. So because we have multiple variables, we have to start in alphabetical order. So the first letter in the alphabet of the ones that I have is X. So I'm going to go with the ones that have just an X. That's this and this. So negative 27 minus 7 is negative 34x. Well, now I need to go to the xy's. Here and here. 1xy plus 1xy is a positive 2xy. Well, now I go to the ones that have just a y. That's this here. Nothing else, so plus 4y. And then the last one, all by itself, is the number by itself, minus 7. So you have to distribute and then combine your like terms to simplify the polynomial. Last one, find the area of each shaded region and simplify. So we have two rectangles, a larger rectangle or a darker rectangle, and then a smaller rectangle or a lighter rectangle. Well, the area of this bigger one is not the full thing because this part is kind of cut out. So we're going to find the area of each one first. So this is similar to number 8 on the first page, where we're using length times width to find the area. So the large is x plus 3 times x plus 2. I will use the box method to find this area. So I have x plus 3, and then x plus 2. So I fill in my box, x times x, x squared. X times 3, 3x. X times 2, 2x. 2 times 3, 6. Like terms are diagonal from each other. So I end up with x squared. 3x plus 2x is 5x. Plus 6. So that's the area of the large rectangle. So now I'm going to find the area of the small rectangle. Well, this time I just have x times x minus 3. So here I can just distribute. It's not really double distribute because I don't have two different things inside the first parentheses. So I really just distribute this x once to everything inside here. So x times x is x squared. X times negative 3 is minus 3x. Well, I want the area of just the dark region. So I have to subtract the area of the light region. Or I want the area of the large, but not including the area of the small. So now, what I want to do is large minus small. So the area of my large rectangle is x squared minus 5x plus 6 minus, in parentheses, x squared minus 3x. Because I have to subtract this whole thing. Well, we saw from the previous examples that if we have a negative in front of the parentheses, we have to distribute. So the first part is going to stay the same. X squared minus 5x plus 6. But the second half is going to change because I have to distribute that negative. So negative or minus times x squared is minus x squared. A negative times a negative is a positive 3x. So just the signs change. Well, now I have to combine my like terms. So we start with x squared minus x squared. Well, they cancel out. It's like if I have $1 and I subtract $1, they cancel out. So now I move to my x. Negative 5x plus 3x. Hold on, guys, I think. Oh, yep, I made a mistake. This should be a positive. We have a positive over here, and I wrote it as a negative. So 5x plus 3x, this is a plus, I had it as a minus. So 5x plus 3x is 8x, and then this 6 is by itself. So it just ends up being 8x plus 6.